How do logicians fit in on the mathematical social circle?
Some incredible theorems and incredible works have been done by logicians.
What did you find inspiring about data science?
Breaking things down and answering the question, why? Data science is like 6 different jobs in a trench coat. You can do many different sorts of things and still be considered a data scientist.
Any general tips along those lines of making your work easily picked up by future readers?
Have those good software engineering practices.
Today it's my pleasure to introduce Travis Nell. Travis received his PhD from the University of Illinois at Urbana-Champaign. For the past 2 years, he's been working as a data scientist. You went to UIUC, you studied logic there. Is it fair to say that UIUC is like a top 5 school for logic?
So at the time I was there, yes, but since then, the faculty involved in the program have all sort of moved on. Like my PhD advisor moved back home to Germany to be closer to his family. There was a retirement. There was one professor, so Anush Saranyan. She and her partner went to Canada. So at the time, it would be considered like top 5 in the world for mathematical logic.
Okay, but yeah, mass exodus kind of changed that one. That's okay.
Yeah.
So in there you studied model theory. So in terms of like subtopics of logic, which is already pretty niche, would you say that's a popular one?
Somewhat. So there's basically 3 or 4 different main subfields of mathematical logic. Okay, I'm just now thinking of more as I tried to count it, but so my research was in model theory. Other people work in descriptive set theory. So that is more related to like mathematical analysis. So if you've done some like graduate level work in analysis, there's this thing called like Borel sets, so on and so forth. So it's sort of describing the complexity of sets and relations. There's axiomatic set theory, that's a different field, where there it's more looking at the axioms of set theory and seeing what follows from those axioms. Because due to Gödel's incompleteness theorem, the axioms of set theory that we usually use, they don't give a complete system. There are things that are independent from them. So there it's independence questions, the most famous of which would be the continuum hypothesis, which is whether there are any uncountable subsets of the real numbers that can't be put in bijection with real numbers. I know that's getting very in the weeds. Then there's like proof theory, which is more related to computer science in the sense that it's about formal proofs. Computer proofs are a really neat thing coming out of that. And then we can throw category theory into the mix as another field of logic. I think I hit most of, there's a bit more that can fit in, but I'd say model theory, descriptive set theory, axiomatic set theory, and proof theory are like 4 big pillars. And how you want to split hairs on that, it's really just how you want to present it.
Or how do logicians fit in on the mathematical social circle?
Logicians are usually pretty chill because one way I've always thought about it is that logic never really gets the big clout. Like, we've never had a logician win a Fields Medal. And generally speaking, like, we're not really that well known in the like wide breadth of mathematics. Even though like some incredible theorems and incredible works have been done by logicians, it never really gets that much clout, even when I think it really does deserve more. So no one that goes into it is doing it because they're like, because of their ego. I've always found it really, really, really just like a very welcoming group back when I was like doing my PhD and my research before I transitioned over.
A chill group of non-ego driven people. That sounds nice.
Yeah.
What did you find inspiring about data science?
I've always liked breaking things down and answering the question, why? And with data science, that is a lot of what the day job can look like. Because it can be like, okay, something comes out of your model and you're like, wait, why is this happening? And then you get to do a deep dive into the data and figure out like why something's happening. And also in data science, I tend to be more on the system side, so building and constructing infrastructure. And I've always liked that aspect of coding and building libraries and just sort of building a structure piece by piece. So that also is something that my mathematical work was very related to, which is sort of building up the theory of a certain class of structures and sort of building something. I wasn't as interested in solving an exact problem, but more in building the structure to make solving problems easier.
You want to build the infrastructure so that other people can have an easier time doing their work.
Yep, that is a major component of what I've done in my work, is building of infrastructure to automate somewhat tedious tasks.
And in your PhD, when you were doing logic, is this something you could use to describe your work as well, or is it not quite?
I'd say it was more taking a class of examples and breaking it down into pieces and trying to sort of build a theory around what categorizes certain examples in certain ways. I'm being a bit vague there because this is not meant to be like my PhD dissertation defense.
You spent a couple of years studying this, right? So
Yeah.
shouldn't be that easy. Yeah. Going from that, so I guess math is more of a kind of at its core, data science is more about inductive reasoning, like using data to inform future decisions.
Mm-hmm.
Whereas math is more of a deductive reason, trying to deduce logical implications from previous things. So, how do you see the interplay between these two things, considering you have experience in both?
So I will say aspects of DS that are more of the elements of DS that are software engineering focused are basically the same as doing mathematics. Like you're writing code, you're writing tests, and that is you can pretty easily make the analogy to a mathematical proof. And in fact, in some areas of mathematics, the analogy of proofs are programs is actually true. The inductive reasoning bit, that can be one of the more difficult things to adjust coming from a mathematical or research scientific background into DS, is you have to accept that like you're making a case for something that you can't prove either way. There's limitations to how certain you can be. But in the end, you need to make your best call as a data scientist on what to recommend to the business, and saying like, the data seems to imply that this is the right business decision to make for our product or program.
Yeah, the difference in math, well, one difference in math and data science is that in math, you're pretty much sure when you, tell people things, and in data science, you're only somewhat sure, I guess.
When you have a recommendation, you need to make it, and you need to be like, I sincerely think this is right, even when it's like, okay, I'm like 70% certain that this is the ground truth, because there's just intrinsically there's just uncertainty in the sorts of things you're saying as a data scientist, and being comfortable with that uncertainty and trying to always make the best recommendation you can. So it's really, that is where I think also having a bit more of a Bayesian understanding of probability can be helpful, where it's like, this is what my belief is of the underlying distribution and where we're at it for making our decision and for grounding it.
Okay, so you mentioned Bayesian is a good approach. Where would you go? Where would you direct someone who doesn't know the Bayesian approach to go learn about it?
For me, the core important idea of Bayesian statistics is there is some distribution for the data that you're looking at, and to update what you think about that distribution as you gather more information about your data. So it really is that idea that like, as we know more, we update our beliefs about the underlying truth, which probably statisticians are like pulling their hair out right now because I'm probably saying things completely wrong. But regardless, that is an important way to think about things when you're practicing as a data scientist, is that you're always updating your assumptions about what your data is like.
Problem I've heard in data science is, in particular in Bayesian, is that for large data, the Bayesian approach can be computationally intractable. So how do you balance that with your what you just said, how it's an important approach?
The Bayesian approach is not so much in the modeling. You can pretty directly include that in how you build models. And you're correct that like principled Bayesian way of building a model will lead to things being completely intractable. I'm using it more as sort of like a philosophical way of looking at things analytically downstream from your already built model. For context, a lot of my actual work is more in monitoring models, in making business, presenting to business stakeholders what we're seeing in different situations coming out of our already built models, and not so much in actually building the models themselves. This also leads to one of my, and this is a little bit rambly, but one of the things I always say is that data science is like 6 different jobs in a trench coat. You can do many different sorts of things and still be considered a data science. And one of my like hot takes is that in the next couple of years or in the next decade, it will fracture into a bunch of different job titles that are just more descriptive of the actual day-to-day work you end up doing. You have to be able to do all of the different jobs, but what you actually do on the job very much can vary a lot while still being a data scientist by title.
You say you like problems that require deep insights. Is that right?
Yeah, so I've always wanted to, and this is how I ended up actually in the specific PhD research I did, is to always keep breaking things down until you reach some sort of like foundation. So that's how I ended up doing work in foundations of mathematics, because there's always another why. Somewhat difficult to manage as a practicing data scientist because you always need to be weighing, is it worth it to keep digging here, or have I got enough insights? It's really the 80-20 principle. And like you need to know when is the time to move on to the next. And that always has been something that is very important for me to keep top of mind, because my natural tendency would be to just keep digging until I understand everything completely.
So what's the 80-20 principle? I guess in theory also, and how do you view it?
80% of the result comes from the first 20% of the effort. So if you want to get 100% of result, it's going to really slow down over time.
How do you interpret it in your everyday work?
It's very important to keep in mind what the criteria for satisfaction for your analysis is, because you can always continue analyzing, but you should keep in mind like this is the bar that we need for this project. Do the analysis, do everything to get past that bar, and setting where that bar is very important, because otherwise you can go down that rabbit hole and like you definitely will keep finding more analysis, but it might be of more value to cut it off when you have enough and then be looking at something else, because you can then make good progress on that. So it's more that like perfect is the enemy of good.
Okay, so deep insights are good. So then on that note, can you tell me about your explorations in the US political subreddit?
Yeah, so you're digging deep. So these are from projects I did because post PhD, I enrolled in a program called Metis, which no longer exists, but it was a 12-week intensive data science training program. So in that one, we were doing, in that unit, we talked about sentiment analysis and unsupervised learning. So there, that project was set up. So I scraped a bunch of subreddits. So interestingly enough, if anyone wants a good like source for text analysis, Reddit actually has it's pretty easy to scrape using existing software. People have built a few libraries that are just really useful for scraping that. So I scraped subreddits, most of which got banned for like far left political. So like back then it was full communism, all the way to the also banned the Donald. And I looked at what the sort of overlaps in sentiments across each looked like, and doing a little bit of language processing, so on and so forth. To get an idea of like what are the overlaps, what are the distinctions between those communities.
You used in a couple of your projects SQL and MongoDB. Can you tell me a little bit about the choice to use that? Because that's actually, I think that's somewhat uncommon for personal projects, and also has it helped you in the long run?
The choice to use that was partly due to the curriculum. Like they required us to like set up SQL for our toy project, but I found it incredibly helpful, even in my day job, to have practiced and done a project where I really did use a set up SQL database, because SQL is a foundational part of being a data scientist. Like everyone at some point is going to have to query their database. Actually, since then, and another piece of advice I have, that one thing that's been really useful is actually to, for common queries, set it up in Python using an object, an ORM. I'm forgetting the exact acronym, but like a lot of what I do goes through templated queries using SQL Alchemy, object relational mapping. I believe that's the acronym, but honestly, I'd say as a data scientist, you need strong SQL skills, but I also think it's important and useful to automate out as many queries as you can. Or in general, I kind of hate when I'm picking up someone else's work and I'm all of a sudden just given a raw SQL file and it's like, how does this query work? Do the tables still exist? So on and so forth. It's much better to have standardized data pulls and have that be part of your team's like general strategy, is to build up the standard data that you need. But ad hoc things will always come up, and then you still need to be able to just write your SQL.
So what's the most lines of SQL code you've gotten from a team member?
In the hundreds.
Hundreds, okay. So not thousands, so okay, good.
How long do the queries get that are generated by our Python code? That goes way up there.
Gotcha. You mentioned you like building infrastructure earlier, or at least seeing infrastructure used to make other problems easier. So what do you think in this respect in terms of like the cloud?
So everything I've done is based on the cloud. Every once in a while, I'll actually do something locally on my laptop, but in general, like cloud is very essential because there's so much standardization that really eases things when you're working in a cloud environment. For example, everyone will be using the same images. So that allows you to, images for your cloud instances. This allows you to centralize like tech, in the sense that if there's a vulnerability somewhere, there's a centralized team that can just fix the image, push that up, and then everyone's using the fixed version. But also, it forces some good habits, because you're required to basically set up your Conda or pip environment. You're required to, or not pip environment, but Python virtual environment. You're required to set up something that is intrinsically reproducible, because every day you'll be reopening a new instance and you won't have sort of that historical debt of things accruing over time where you've changed a little bit here, a little bit there. So it enforces good software practices and making things reproducible. And that, I do think, is one of the biggest things I think every data scientist should focus more on, is good software engineering practices. It is by far the thing that, and I'm not claiming that I'm perfect at it, but I think that is by far one of the biggest time sinks, is when you're picking up some work from someone else and they haven't used good software engineering practices. It can all of a sudden be like you have to track someone down to get data that they had on a table that's no longer there. Cloud compute is one part of that, but it's part of a bigger thing of making sure that your analysis is meant to be picked up by someone else that you may not even know. They might be hired to your company 5 years from now, and they should still be able to carry on your work.
Any general tips along those lines of making your work easily picked up by future readers?
Yeah, so one useful thing is to have those good software engineering practices. So CI/CD, so continuous integration and continuous development. So making sure that there are automated checks, that you can't put in an analysis into your GitHub, GitLab, or whatever version control software you're using. You can't even merge a branch unless it meets a certain bar. Now, is that always fun? No, but what it does do is it makes sure that everyone is coding to the same standard, which is good for removing idiosyncrasies and just holding everyone to that certain standard. Now, you don't do this because you love a certain way of formatting your code or your notebooks. You do this because otherwise you'll be arguing about hey, you should use tabs rather than spaces, which is a old school argument on code formatting. Or you'll be arguing about format of in Python, a doc string, so on and so forth. By just setting that up ahead of time to be to merge into this repo, you must meet these standards. It removes those from debate. And then actually when you're writing code or reviewing others' code, you are actually just reading and reviewing the code rather than any sort of aesthetic component to it.
Do you see any technology in the future that'll make it easier to infrastructural changes that'll make it easier for either developers, data scientists, or even more generally?
One existing technology that I really like is, so for Python, there's something called Black, which is it's a automatic formatter. It will take in your Python code, it will format it, and it has essentially zero configuration options. It's very opinionated, but it's fine. There are a lot of good opinions on how to format, but I'm saying that institutionally, what's right is to just pick one, enforce it across the board, and just be this is how we do things, and force all the code to be formatted in that way. So in the future, I'm not sure. There's lots of interesting stuff going on with for coding, generative AI models. Chat GPT right now can sometimes write useful code with just a simple prompt. So I think that can be a really interesting future technology towards easing the coding burden, but it's not mature enough yet.
AWS, for instance, or the cloud in general, revolutionized the way we, store and access data. And, do you see anything like that in the future that you're looking for that might revolutionize in the way that, say, the cloud did?
Yeah, I think in general, and a friend of mine worked a lot in this, academically, but more automated, code refactoring or just smarter ways to automatically help people write better code, not on a syntactical level, but a semantic level where it's helping your code actually, I guess syntactic and semantic might not be the right words there, but do larger structural changes to existing code bases in an automated way. That is a potential thing. Only really know about this because someone I went to undergrad with has done a lot of research on sort of automated intelligent refactoring. And that could be really useful because one of the biggest things holding back DS programmer, anyone that needs to touch code, is inertia, because the longer things go institutionally, the more legacy code you'll have. And being able to more quickly shift that around, I think that can be very freeing because tech debt is very difficult and also often hard to prioritize in a business context to remove.
What was your job search like back in the day when you were applying for jobs?
The job search was actually very luck-based in the sense that a friend of mine had been reached out to by a recruiter from the company, and I asked him to pass on my name. So it was through a friend of mine getting just DM'd on LinkedIn and passing on my name. And then I got DM'd on LinkedIn. And then we went through the usual interview process, which included some amount of like technical interview, some amount of on-site interview, and prior to the on-site, there was a level of take-home. But this all was set out in the initial call with the recruiter, what the process looked like. So it will vary company to company and over time, but it was very, very transparent what these stages were, what things look like, where you're at, so on and so forth. So very good communication.
And job search lasted how long? Did you have to do other interviews as well?
So I did other interviews. I tried to play the nepotism card because my dad is a software engineer, so he knew some people that were data scientists. So through him, got in contact with some people on LinkedIn that eventually also came to a job offer, but that fizzled out at the point of talking about compensation towards the end. They were not willing to pay as much as my current employer.
Do you do, or maybe more generally, what kind of stuff is being done there in terms of data science?
So generally speaking, there's a lot of ways that machine learning can be used at a major bank. So as a lender, every bank has ways of assessing risk. When someone applies, you want to make sure that you think they're likely to pay off the debt. So every bank will have some sort of procedure there. For very small banks, it might be just like take your FICO score from one of the 3 consumer bureaus. Of course, you can get a lot more intricate than that, depending. But there's other things, like when you use your phone's mobile app to deposit a check. So you take a photo of the front and back of the check. That is using machine learning for image processing to read off like the information on the check. So that's another way that machine learning can be used. Is this transaction fraudulent, or is this applicant fraudulent? So looking at addressing fraud, every major bank will have some sort of system in place to address fraud across the board. So that is when you are just like, you randomly decide to spend $2,000 on Amazon for a telescope or for whatever, and they're like, this seems a little suspicious. Let's make sure that it's actually them. That will be being triggered by a similar sort of model. And this is only scratching the surface of what's out there.
So one interesting thing that's coming about with these generative AI, it may be tough to tell in the future whether something is real or generated by AI. How do you view this in terms of like fraud detection? And do you have any insight there?
It will definitely make things more difficult in the future. However, one of the key things about generative AI is you're training your generative network and your adversarial network together. If you don't have the ability to train against the fraud model, then you can't really train the generative bit to beat it. Personal first idea with respect to that is it's not going to be that bad for fraud models, because really interesting thing about these generative models is structure of it being a self-reinforcing loop where you're training the generator to fool the adversary and the adversary to detect the generator. But when those are split, when the adversary is a trade secret held away from you, unless you want to try to train your model by committing billions of dollars of fraud or something like that, you're not going to be able to train the generator against the adversary on the other side.
Yeah, so that would be for when you have a generative and adversarial. But so what about these models where like, video generation or audio generation, where they generate something that, sound exactly, or it seemed like it sound very close to the real person?
Yeah. So that really needs to be handled by thorough multi-factor authentication. So you might be able to meaningfully generate a fake call to like the business, unless you can also somehow spoof that second factor of authentication. It's not going to work. So that is, I think, that's why it's really important to have multi-factor authentication for all important like accounts, logins, so on and so forth.
Yeah, okay, I'll go set those up right after this meeting then.
For anything that's important, like if it's really just like you have it connected to your Gmail and you can just reset it, so what? Like those, it's very important to have important things be very secure.